Absolutely. Thank you so much for having me here. It's amazing to see everyone talking about standards and specifically DIDs and portable memory. This is something that we've been thinking a lot about. And today, I only have 5 minutes, so I'm going to brush through about a year of work, which is taking a long time, and we have a lot of learned lessons. So first off, my name is Cameron Dennis. I've been focusing in your ecosystem for the last 5 years or so, building crypto for about 10, AI really for the last two. I joined primarily because of the two co-founders were trying to formally verify the entire internet using AI. Near started actually as an AI company back in 2017. One of the co-authors of Attention is All You Need is one of the co-founders. And the whole point was to build the open web because the concern was, well, if superintelligence ever does come to fruition, it's going to exploit every vulnerability on the internet, and we're going to need to formally verify everything. And I'm not going to walk you through the entire path towards this vision of user-owned AI, but the goal is, people need to actually own their money, data, and governance. But the first step is to build this distributed database that actually scales. So we had to do that. We did that through building a sharded blockchain. Second piece is making sure that all these networks are completely interoperable with each other. We call that chain abstraction. The product there is called near intents. We'll walk through that in a bit. And lastly, this is sort of the commerce layer and liquidity layer for user-owned AI. This led us to just a couple quick stats. We have had over 43 million people touch the protocol in the last month. The intense side of things is really growing. We hit $7.4 billion. There actually should be an extra 3 sets of zeros there recently. And that is, we're seeing a lot of success here on the chain abstraction piece. The very last piece, again, is that user-owned AI. The vision here is to ensure that, the whole web is going to change. So we do believe in a future where your assistant is going to action on your behalf, given your intents, and it's going to need to connect to all these different agents. And so we started by building an agent interaction transaction protocol. This was last January. And the whole point here is for agents to discover each other, to pay each other, to do some sort of security check on each other. So you're able to, easily and securely transact. So next part is we actually had to build the agent interaction transaction protocol. We built an agent framework. This agent framework, we got thousands of agents built. We spent a long time building an agent community. And so we've, hosted so many hackathons, got thousands of agents built, have a Python SDK, TypeScript SDK, only to realize agents, we need useful agents. Like none of this is actually relevant until we actually have agents that are meaningful. And so, because we're very excited about this future of agentic commerce, was an early adopter of the X402 standard. We created an open agents alliance with Coinbase and a bunch of other companies dedicated to this, agentic future. And we even built an on-ramp for agents because if agents are going to need to pay for things, well, they need crypto. And we do believe that agents will be transacting in crypto across any network, across any asset. And that's where intents comes in. And so we built this, like this exists. But the missing piece is useful agents. And so that's where we actually decided to wind down all of the agent work, except for something called shade agents that we're dedicated to, which are verifiable private agents, but we can get to that later, in order to focus on verifiable privacy. Because if agents don't have verifiable privacy, well, companies that we've spoken to like Cloudflare and others they're just not going to adopt them. And so my main work right now is focused on verifiable private inference, but we have another team dedicated to agents that you don't have to trust and you don't have to actually open source the code in order to trust them to make sure that they're doing the things that you think that they're going to be doing. That's called the shade agent framework. There's a QR code on the slides that I'm happy to send to everyone after. We also worked with another team very closely to build a useful agent. This useful agent is called Trav AI. If you go to my Twitter, I was talking about it earlier this week. It launched last Friday. And in order to actually build useful agents, you need access to company data. You need access to their internal tools and everything else. And so we worked with an organization called IHC and AdiChain to build a travel agent for all of the employees that IHC, it's a holding company and like very large asset management firm out of the UAE that owns everything from hospitals to travel booking sites to hotels and everything, airlines. And so the whole point is they have the data. They have the access to actually use agents to save money and time. And so we did recently just announce this useful agent called Trav AI. And the goal here is to then take that and more generalize it for everybody else. And so now we actually have an agent that is actually warrants demand for to be paid for other agents. And so that is live today. Well, it's live for the employees of IHC. It's like an enterprise use case here. But that is something that is we think is a prerequisite to mass adoption. Is we need to do this internally inside of companies, prove that it works before we go out and say, hey, everyone, we need all these standards and everything else. Because right now we did this. A lot of agents aren't ready for real world adoption. The best agents right now are primarily coding agents, and a lot of them don't necessarily need all these standards quite yet, is from what we've realized. And so last but not least, I can talk a little bit about the Shade Agent framework. This is built by a team called Proximity Labs. And the whole point is that these agents run inside of these trusted execution environments, TEEs. And you can think of them as secure enclaves. They've been around for a little bit, primarily on the CPU, and now they're actually on the GPU. So you're able to load very large models inside these machines in order to verify access and privacy. And so you can essentially encrypt a prompt or have an agent encrypt the code, throw it inside a TEE, then decrypt it, run inference on it, run whatever you want on it, verify it, encrypt the response, send the response back to user, and now you've been able to verify privacy along the entire way. Super exciting stuff. Again, we built an entire private inference network to enable this. And we actually have a couple live agents today that are trading on behalf, because if you want to use an agent that's trading and managing money for you, you don't want that to be just ruggable, essentially, like someone able to change the code and you not have any idea. There's also incentive for the agent developer not to open source everything, because that is their bread and butter. And so you need the sort of middle ground of verifiability and privacy, and that's what the Shade Agent framework provides. We have the agent evals, and so agent evals are a prerequisite, because if you can't tell that your agent's doing something relevant, then I think your agent's kind of useless. And so we're working very closely with a company called Silverstream, and they're working with a lot of the top labs that and around essentially creating an agent eval framework to test to make sure that your agents are doing the things that you think they're doing well. And so there are common computer use agent benchmarks and frameworks in order to make sure that we're driving real value to companies. And so that's the gist. And if you want to learn more about any of the things I mentioned, you can message me on Telegram or Twitter. I'm Cameron_Dennis on Twitter, and Telegram at Cameron Dennis.